Okay, quotients with radicals. Quotients. Remember what quotient means? Quotient is the answer to a division problem, okay? So these are all going to be division type ones, okay? So there's special rules when we do stuff with quotients and the radical symbols. So the main thing we're going to be worrying about here is called rationalizing the denominator. So denominator, we remember, is the bottom of a fraction, right? So basically what it means is we want to make it so the bottom of our fraction is a rational number, which would not be something with a square root, okay? So you can never leave, well, in proper form, you can't leave a radical or a root on the bottom of your fraction. That's not good form, okay? So we're going to go through some steps here to basically undo that or get it off of the bottom, okay? So there's a couple different options here for rationalizing the denominator, pending what you start with. So the first one, if the denominator, and again, that's the bottom of the fraction, is just a radical alone, so just like a root of something with something underneath it, you want to multiply both the top and the bottom by something to make that radical go away. Okay, so there's an example of it here. So like say we had 1 over square root of a. Again, not proper form to have a square root on the bottom, so what you do is you multiply by the square root of a on top and bottom, because if it's on the top and the bottom, that's the same as 1, so we're not changing its value at all. And then what happens there is when you do a square root of a times the square root of a, the square roots end up canceling out, and you're just left with a, and then your square root moves to the top. Okay, so then that's in better form because the square root's on the top and not the bottom. It gets a little bit more confusing when the value you have on the bottom is a binomial. Binomial just means it's like two terms, so like, you know, something added or subtracted to like a square root, so something kind of like this here. So if you have that, you want to multiply the top and the bottom by the conjugate of the denominator. And I think we did some with conjugates when we did the I stuff, but a conjugate is basically where we have like something like this, so like a plus the square root of b. Then we take it and we switch, so we keep the letters and stuff exactly the same, but you switch the symbol in the middle. If it was add, you switch it to subtract. If it was subtract, you switch it to add. And then what you're going to do is you multiply both the top and the bottom by that complex conjugate, and then that makes the bottom no longer have a square root. Okay, and you can kind of see that in that example. And what we're going to do is I'm going to do an example in our packets that's kind of like that as well. Okay. And then similar to what we were doing with yesterday's stuff, when you're simplifying these out, you want to make sure you take out as much from underneath the radical as you can. So like if it was like square root of 20, you remember how we took 20 and broke it down and did all that stuff yesterday? You want to do that same stuff too if, you know, you have something kind of like that. Okay? Okay, so let's take a look at our examples then. So there's one of each. So there's one where it's just a regular square root, and then there's one where it's like an add subtract one, so we'll do one of each. So here assume our a is greater than 0, so just positive number basically, and we are supposed to rationalize the denominator. Okay, so my first thought here is if I've got this fraction, 5 over the square root of 45x, what I want to do is I want to follow what they did here. So here we had that square root on the bottom, and we took and we multiplied by whatever that square root was on the top and the bottom. So here we've got the square root of 45x, so we want to multiply this fraction by square root of 45x over square root of 45x. Okay, and we can do that because if I have something over the same exact thing, isn't that whole thing equivalent to 1? So if I multiply that by 1, it keeps it the same value. We're just manipulating it so it looks like something that is more in favor of what we want. Okay. So what is going to end up happening here is when you multiply square roots that are identical to each other on the bottom like that, what'll happen is it's basically like taking square root of 45x squared. And what happens when we square and square root? What happens to those things? They go away, right? Because they kind of cancel each other, and it's because it's, you know, something times itself that it's squared. So really we're going to be left with just the 45x there on the bottom. And then on the top, we'll have the 5 still. And under our square root, we still got square root of 45x. Then what we want to do is we want to see if we could keep breaking this down further with like that 45 there. So then this is where we go to what we were working on yesterday. where we take that 45 and break her down. So if I took that 45 and broke her down, what could I go to for 45? Be 5 and something because it ends in a 5. 9. And then 5's prime. 9 could go down to 3 and 3, right? So 45 would be the same as 3 times 3 times 5. It was a square root question, right? So if it was a square root, that would be 2. So that would make a group of 2. 5's going to stay under our radical, right? Because there wasn't another 5 to pair with. So we pull a 3 from there. That guy's staying underneath. And then it also had an x with it. And the x is just a single x there, so we can't do anything to pull that out or anything. Like if there was 2 of them, we could pull it out or whatever. But since it's just a single one, we got to leave her under there still. So now up top here, we'll have 5 out front times, and then now we're switching that square root of 45x to what we had it simplified to. So 3 times the square root of 5x over 45x. And then because you have these just like regular numbers here, like a 5 and a 3, you could multiply those out. So like 5 times 3 would be 15 times the square root of 5x over 45x. And then there's one more step we could do here. Any ideas on the last step?
15
Yeah, 15 and 45, right? Because couldn't you divide both of those by 15? So if you pull a 15 out of that, it goes down to 1. 15 out of the 45 would go down to 3. So if that's just a 1 there, we don't really need it. We can just leave it as square root of 5x over, and then that 45 reduced down to a 3, so 3x. And then we got to stop at that point. Sometimes people are like, well, I got an x on the top and an x on the bottom. This one isn't just an x, though. It's a square root of x, which is a little different, okay? So then we got to just stop at that point. Then we're done, okay? So it's a little bit complicated because you got to do the rationalizing stuff and then, add on what we've been working on. But it's all stuff that I believe that we can do. Okay, next one here. So this is one more similar to the second one here, where we've got to use the complex or the conjugates of it because they are like a binomial where it's 2 things added or subtracted. So like here, same thing. So I'll start with 2 over 3 minus the square root of 5. So again, in this case, it's bad practice to have that square root on the bottom, but since we have some extra stuff in there besides just that square root, we can't just use the same exact method as before. We have to multiply it by the complex conjugate. So if this is subtract, we just switch it to add. Pay attention over there, or are you on your phone? So you keep everything the same, but you switch it to add. And then whatever you do to the bottom, you do the same exact thing to the top, because again, that would reduce down to 1. We're just manipulating it in our favor here. Okay, and then what's going to end up happening here is it's basically like we're kind of distributing the 2 across to both of those things. So like if I took 2 to the 3, that would be 6. If I took 2 to the square root of 5, it would just be 2 times the square root of 5 over. And then the bottom here, if we're doing a binomial times a binomial, so it would be kind of like 3 minus square root of 5 times 3 plus square root of 5. Isn't that like our FOIL stuff we were working on before? So we would want to go like first times first, so 3 times 3 would be 9. Outside would be 3 times the square root of 5, so 3 times square root of 5. Inside would be negative square root of 5 times 3, so that would just be negative 3 times the square root of 5, or minus, either way. And then our last there would be negative square root of 5 times square root of 5, so you'd have negative because it's a negative times a positive. And then similar to what we had before, when we do square root of 5 times square root of 5, isn't that like square root of 5 squared? So wouldn't that just cancel out to be 5? And again, it's minus or a negative there because it was a negative times a positive. And then what's always going to happen on these when we do conjugates is these middle ones are always going to cancel because one of them's positive and one of them's negative. So those middles will always go away. And then you'll be left with like 9 minus 5, and we know 9 minus 5 is 4, right? So then that whole bottom would end up just canceling out to a 4. And then again, there's one more step we could do here. So not just the 6 and the 4, also the 2. So to be able to reduce here, everything has to be able to reduce, okay? So what you could do is you could think of this separately, like if it was like 6 over 4 and then 2 square roots of 5 over 4, that means the same thing. And then you would want to reduce them down separately, okay? So like here, if I was reducing down, 6 over 4, pull a 2 out of each of them, that'd be like 3 over 2, right? Plus, and then here, and that was 3, 2. Here, same thing, we could go 1 there, 2 there if I pull a 2 out of each of those. So it'd be like square root of 5 over 4. Or not 4, 2. And then I'd be cool if you left it at that step right there. This wants you to write it in like this A plus B, C form. So if they want you to do it like that and they say something about like what's the A, what's the B, what's the C on the assignment or whatever, they're just asking you to write it out as separate things. So like 3 over 2 plus, and then they just want you to write the B and the square root thing separate from each other. So like you would leave the 1 back up there and it'd be like 1/2 times the square root of 5 just to be in that form. But if it doesn't ask you to do that, like I don't care. Like this is the same as this, so I'm cool with this because it's simplified all the way down. Technically, you could also put this back together since they're both out of 2. You could also have it as like 3 plus square root of 5 over 2 if you wanted to. All of those mean the same thing, so I'm cool with any of those. Okay? Okay. All right, so that's it for notes here. So you got that book page there for Monday. So 3 to 18, and then we've got 2 more sections left in this chapter.